Car. A car is a road vehicle designed to transport people using its own power. The first practical automobiles appeared during the late 1800s after inventors developed compact internal combustion engines. Before that, most people relied on horses, bicycles, or trains for transportation. Cars exist because people needed a faster and more flexible way to travel without depending on animals or fixed railway lines. By combining an engine, transmission, steering system, and wheels into one machine, engineers created a vehicle that could travel almost anywhere roads existed. One surprising fact is that there are now more than 1.4 billion cars on roads around the world, making the automobile one of the most widely used machines ever built. Today, cars transport people, deliver goods, support emergency services, and form the backbone of transportation in many countries. Engine. The engine is the machine that produces the power needed to move a car. The modern gasoline engine was developed during the late 19th century by inventors including Nikolaus Otto and later improved by engineers such as Carl Benz. Their designs made practical automobiles possible. Most cars use an internal combustion engine. Inside the engine, fuel mixes with air and is ignited by a spark. The tiny explosion pushes a piston downward, converting chemical energy into mechanical motion that turns the crankshaft. The engine works this way because gasoline contains a large amount of stored chemical energy that can be released quickly inside sealed cylinders. One surprising fact is that a typical car engine can perform thousands of combustion cycles every minute, with each cylinder firing dozens of times every second while cruising on the highway. Today, gasoline, diesel, hybrid, and electric powertrains are used depending on efficiency, performance, and environmental goals. Fuel system. The fuel system stores fuel and delivers the correct amount to the engine. Early automobiles used simple, gravity-fed fuel systems and carburetors. As engines became more advanced, engineers developed electronic fuel injection to improve performance, fuel economy, and emissions. The fuel pump moves gasoline from the fuel tank to the engine. Fuel injectors then spray an extremely fine mist into each cylinder, allowing it to mix evenly with incoming air before ignition. This precise delivery is important because the engine operates most efficiently when the air and fuel are mixed in nearly the correct ratio. One surprising fact is that modern fuel injectors can open and close hundreds of times every second, delivering incredibly small and accurate amounts of fuel. Today, electronic fuel systems constantly adjust fuel delivery using sensors, helping modern engines produce more power while using less fuel. Transmission. The transmission transfers power from the engine to the wheels. Early automobiles used simple, manual gearboxes because engines could only operate efficiently within a limited speed range. As cars became more advanced, automatic transmissions were developed to shift gears without driver input. A transmission works by changing gear ratios. Lower gears multiply the engine's torque, making it easier to start moving or climb hills. Higher gears reduce engine speed at higher road speeds, improving fuel efficiency and reducing wear. The transmission exists because a car engine cannot provide maximum power and efficiency at every speed using a single gear. One surprising fact is that many modern automatic transmissions have 8, 9, or even 10 forward gears, allowing the engine to stay in its most efficient operating range almost all the time. Today, cars use manual, automatic, continuously variable, and dual clutch transmissions depending on performance, comfort, and efficiency. Differential. The differential allows the drive wheels to rotate at different speeds. The differential became common in the late 19th century as automobiles became practical for everyday driving. Engineers quickly realized that both drive wheels could not always turn at exactly the same speed. When a car goes around a corner, the outside wheel travels farther than the inside wheel. The differential automatically allows this speed difference while continuing to deliver power to both wheels. Without a differential, the tires would skid, wear out quickly, and make steering much more difficult. One surprising fact is that high-performance sports cars often use limited-slip differentials, which automatically send more power to the wheel with better grip during hard acceleration. Today, differentials are found in nearly every rear-wheel drive, all-wheel drive, and four-wheel drive vehicle. Steering system. The steering system changes the direction of the front wheels. The first automobiles used simple mechanical steering, similar to horse-drawn carriages. As vehicles became heavier and faster, engineers introduced power steering to reduce the effort required by drivers. Most modern cars use a rack and pinion steering system. Turning the steering wheel rotates a gear that moves a metal rack from side to side, causing the front wheels to pivot. This system exists because even small steering wheel movements need to produce precise wheel movements while giving the driver complete control. One surprising fact is that many modern cars use electric power steering, which only provides assistance when needed, helping improve fuel efficiency compared with older hydraulic systems. Today, advanced steering systems can even help drivers stay centered in their lane using cameras and onboard computers. Suspension. The suspension supports the car while absorbing bumps from the road. Early cars cars had very stiff suspensions adapted from horse-drawn wagons, making rides uncomfortable on rough roads. Engineers later introduced springs and shock absorbers to improve comfort and handling. A suspension system uses springs to absorb impacts and shock absorbers, also called dampers, to control the movement of those springs. This keeps the tires in contact with the road while reducing bouncing. The suspension exists because tires must remain firmly connected to the road for effective steering, braking, and acceleration. One surprising fact is that some luxury cars use adaptive suspension systems that automatically adjust their stiffness hundreds of times every second to match changing road conditions. Today, modern suspension systems provide a balance between comfort, stability, and precise handling in everything from compact cars to high-performance sports cars. Braking system. The braking system slows down or stops the car. The earliest automobiles used simple mechanical brakes that pressed against the wheels. As vehicles became faster and heavier, hydraulic braking systems replaced them because they provided much greater stopping power. Modern cars use disc brakes. When the driver presses the brake pedal, hydraulic fluid transfers pressure to brake calipers. The calipers squeeze brake pads against a spinning metal disc attached to each wheel, creating friction that slows the vehicle. The braking system works because friction converts the car's kinetic energy into heat, allowing the vehicle to lose speed safely. One surprising fact is that during a hard stop, brake discs can reach temperatures of more than 500 degrees Celsius, becoming hot enough to glow under extreme racing conditions. Today, most cars also include anti-lock braking systems, or ABS, which prevent the wheels from locking during emergency braking and help drivers maintain steering control. Electrical system. The electrical system powers the car's electronics and starts the engine. Early automobiles had very few electrical components, but as cars became more advanced, electricity became essential for lighting, ignition, computers, and safety features. The battery supplies electricity when the engine is off and provides the power needed to start the engine. Once the engine is running, the alternator generates electricity and recharges the battery while powering the vehicle's electrical systems. This system exists because modern vehicles rely on dozens of electronic components that require a continuous supply of electrical power. One surprising fact is that many modern cars contain more than 100 electronic control units, each operating a different system, such as the engine, brakes, airbags, or climate control. Today, electrical systems support everything from touchscreen displays to advanced driver assistance technologies. Tires. Tires are the only parts of a car that make contact with the road. The first automobiles used solid rubber tires, but pneumatic or air-filled tires became popular in the late 1800s because they offered a smoother ride and better traction. Tires work by creating friction with the road surface. Their tread patterns channel away water, improve grip, and help maintain control in different weather conditions. They exist because engines, brakes, and steering systems can only work effectively if the tires maintain a strong connection with the road. One surprising fact is that the combined contact area of all four tires touching the road is roughly the size of 4 sheets of paper, yet that small area supports the entire weight of the vehicle. Today, tire technology continues improving with specialized designs for fuel efficiency, high performance, winter driving, and electric vehicles. Modern cars. Modern cars are highly engineered machines made up of thousands of components working together, from the engine and transmission to the suspension, brakes, steering, electrical system, and tires. Every part has a specific job. Each system depends on the others to deliver power, maintain control, provide safety, and transport passengers efficiently. One surprising fact is that a modern passenger car contains more than 30,000 individual parts, all designed to work together with remarkable precision. Today, cars continue evolving with hybrid systems, fully electric powertrains, artificial intelligence, and autonomous driving technology, making transportation safer, cleaner, and more efficient than ever before.